MCV4U, Chapter 4, Lesson 2, Critical Points. New term, and it sounds important. Actually, it sounds more than important. It sounds critical. As we'll see, it's not that big of a whoop. It's something that we've actually talked a little bit here and there, but we're going to give it a fairly formal definition today. Hopefully you've done this warm-up. And I bet you I tricked you a little bit. We've got that the first derivative is 0 at some point. What can you say about f of a? And probably you said we've got a max or a min, right? Because usually that's what we think of. We think of, okay, yeah, there's a, and the first derivative is 0, so we've got a maximum, or perhaps we've got a minimum, right? Like that. And often that was the case, but we also saw functions where this didn't happen. We'd like to say that f at a is a maximum or a minimum, but we can't. We saw functions like this where the f prime at x was increasing 0, then increasing again, or decreasing 0, then decreasing. The derivative rather was negative 0, negative. This sort of slide action, right? Well, what else would we need to know in order for us to have a maximum or a minimum? What we'd have to have here is, instead of having this negative 0, negative, or positive 0, positive, this is what we want, right? We want this is a minimum max, right? Where it's increasing 0, decreasing. This is the first derivative I'm talking about. Decreasing 0, increasing. This gives us a minimum maximum. So the first derivative is equal to 0 is not enough, right? We'd like to see if it changed sign, right? So what more would we like to know or calculate? We'd like to know what the derivative was a little bit to the right and a little bit to the left. If we had these two calculations, then we would be able to fill in our sign chart and be able to determine whether it was a maximum or a minimum. That's the key here, okay? And that's the key to finding critical points. So critical points, this is don't write on me, but I never gave you this sheet, so you can write on it all you want to. You printed it off yourself, and hopefully yours looks good. There's a lot of information on this diagram, and I'm going to be going through this. It says for a function f, c is a critical number if f at c exists. So it has to exist. It can't be undefined there. And f prime at c equals 0, or f prime at c is undefined. So it's 0 or undefined. Then it's called a critical number. As a result, when we substitute in and get the y coordinate, c f at c is a critical point. Okay, so we got the first derivative is 0 or undefined, but f at c has to exist. So let's have a look at some of these points. So we'll read them kind of from left to right and then mark up our diagram. So at A here, we've got f prime at x, there's A, is 0 there. And it's decreasing, 0, then increasing. Right, over here, B, it's 0 at B, but it's increasing to the left and decreasing to the right. What else do we got? C, 0 there, not 0, right? This is a cusp, so it's not 0 there. It's actually undefined there, isn't it? But it's negative on the right, there's C, and positive on the negative on the left, positive on the right. And here, notice that D, and this is what this is pointing out, at D, it's undefined at, the derivative is undefined at D. Notice the function is defined. The derivative is undefined because this is another one of these cusp deals. It's positive there and negative there. at those x values, a, b, c, and d, the function's defined. We've got there's no holes or there's no discontinuities. And the derivative is 0 or does not exist. So there it's 0, there it's 0, does not exist, does not exist. So all these points are critical points. Okay? And the idea is we'll investigate critical points to determine whether they're maximums or minimums. Okay, hopefully you got that idea about a critical point. So it says every local maximum or minimum value of a function will occur at a critical point of the function, since peaks and valleys of a graph occur where the tangent is horizontal or does not exist. So this is kind of like I talked in the last video, the CMC course where it has a lesson on the extreme value theorem, EVT. And that's what this is, the extreme value theorem. But this is the quick way to state it without any proof or anything like that. But this leads to the first derivative test, and the first derivative test is what we talked about yesterday. So if f at c is a local minimum or maximum, then f prime at x will change its sign at c. Oh, it'll change its sign. That's what we saw in all those places. It went from negative to positive. It went from positive to negative. Even though it wasn't defined at f equals c, it went from negative to positive. And at d, it went from positive to negative. It changed sign. It wasn't those cases like back in the warm-up question, it stayed positive or stayed negative, even though it was 0. So for a critical point to be a local extremum, it has to change sign. So f prime at x changes from positive to negative, then f at c is a local maximum. So it changes from positive to negative. So this is positive, and then 0 or undefined, 0 or undefined, and then negative, positive, blah, negative. Yeah, it's going to be a maximum. This one, otherwise it's a minimum. So I'd have the first derivative. This is the first derivative I'm talking about again here, remember? First derivative is negative, and then 0 or undefined, and then positive. Yeah, it's going to be a minimum. And it says some critical points are neither local maxima nor local minima. And these are the ones we were talking about in the warm-up. This occurs when f prime at x does not change its sign at c. Examples of critical points which are not local maxima and minima are given below. So this one we have at x equals 0. We have the first derivative is 0, right? The first derivative is 0. On the left, it's increasing, and on the right, it's increasing. So f prime at x is positive, 0, positive, and we see it's not a local maximum or a minimum. It doesn't change sign. So on this one, for instance, at x equals 0, we have vertical tangent. The first derivative does not exist, but it's increasing. The function is increasing, which means the first derivative is positive, and then it's undefined, and then it's positive again. X equals 0 is not a local extreme. It's a critical point. It's a critical point, but it's not a max or a min because the first derivative doesn't change sign. Okay. Some sort of technical definitions, but I think it'll make sense once we get into an example. And we're going to get into an example in the next video, I believe. Yep, let's go on to the next video.